is go within one revolution, and that will become either your first positive or your first negative coterminal. This one starts positive, so I have to back it into one revolution to get it to its first positive coterminal. And then I back it out one more time to get to its negative. This is the same thing as 2 and 2 pi over 5. Well, this is really easy to find the positive coterminal. It's 2 pi over 5, right? Because this would back out to 2 pi. That gets your positive. To get to your negative, you subtract 2 pi out of it. Well, when you subtract 2 pi in terms of fifths, it's 10 pi over 5. And you get negative 8 pi over 5. Those become your 2 coterminal angles. Okay. Same thing goes when you have the in degrees. The degree one, what was it, 900? Does that sound right? Okay. 900 is beyond 2 revolutions. 720 would be 2 times around. Okay. So if I back out 720, there's my positive. I'm within 1 revolution. I subtract 360 again. There's my negative. That's all you have to do. That's all you have to do with those. What was the other one then? The other one, 7 pi over 12. That one's pretty easy. It's within 1 revolution. You just add and subtract 24 twelfths to that. And then the other one I think was what, 3 or 540? 340. So 340, in that case, it's within 1. All I have to do is add and subtract. So I made sure I gave both sets had something similar of that type to it. When it goes to radians, degrees, again, when you start with radians, if you start with radians in terms of 13 pi over 4, to get 2 degrees, you have to make sure that you multiply by 180, divide by pi. You want the pi's to drop out. So you put 180 over pi. Okay? Pi's drop. And I wanted to make sure that you had values that, even though it looks like it's going to be awful to try to figure out, 4 into 180 is 45. Because half of 180 is 90, half of that is 45. There's your fourths. Okay? So all you had to do then was multiply out 45 times 13. We should be able to do long multiplication by hand if we need to. 12 gives me a 13, a 5, and a 4. 585 would have been your degrees. Okay. The degree on that one was the 165. Multiply it by pi, divide it by 180. You have to start backing out common denominators. I wanted to make sure it was set up where you can see 5 and a 0, which means you take out a 5. Okay. You take out a 5, 5 goes into 16 3 times, there's 1 left over, there's a 3. 5 goes into 180, so 5 goes into 18 3 times, there are 3 left over, leaves you a 6. Those are both divisible by 3. 11 pi over 12. I saw people trying to do long division with all of that stuff the whole way through. They're not supposed to be like that. You guys need to look at the fractions and go with the easy stuff. Okay? Go with the easy stuff. Excuse me. You could have done this one by 12 also if you really wanted to get, or not 12, I'm sorry. You could have done it by 3s and whatever. And then the other one had, what was the other one? 13, 65, it was, negative 2 pi over 3. That one should have been easy. Negative 2 pi over 3 again, times 180, divided by a pi. Pi's go out, 3 goes into 180 6 times, or 60 times. So you have negative 120. And then the last part in there was the 210. Going 210, again, I wanted to make sure that you guys saw, slap a pi next to it, go by 180. Zeros drop, they're both divisible by 3, and it gives you 7 pi over 6. That's how fast these things should have been. So I was harping, you had 5 minutes to do this, you should have been done in 5 minutes. Okay. I'm not sure where the disconnect is going again with some of these things, but it's there. Okay, it's there. That's frightening Guys, this should have been the simple stuff. Okay. Now, as far as the excuse me, as far as the homework and stuff was concerned from last night, I've been getting lots of questions again about how this stuff looks, how this stuff works. When you're setting these things up as you're making them go, you have to plot it. You have to figure out where, or so you have to first figure out what quadrants are you looking at, where are you trying to solve for the problem as you're going through. The rules for inverse trig functions. Remember, sine, you're searching for sine inverse between pi over 2, negative pi over 2. You search cosine inverse 0 to pi. And then tangent inverse, non-inclusive pi over 2 and negative pi over 2. And remember, what I mean by non-inclusive is that it's undefined at pi over 2 and negative pi over 2. Okay? So as you go through these, you have to figure out which setup you're going through. Yes, ma'am? So if we look at 20, tangent of 1. So in order for it to be a positive tangent, it has to be first quadrant, okay? You have to think first quadrant. Oh, that's the other thing. I've noticed a lot of people are not drawing the reference angle side back to the x-axis when they're doing their work, okay? Your reference angle always comes back to the x-axis. Whenever you draw out, go down or go up. You don't go left and right. You never do that. You'll be wrong every time. Okay? So here, if I have reference angle and I got to figure out what triangle gives me sides of 1s, you have to know your special right triangles. These are the only two that you worry about. 30, 60, 90. And then you have a 45, 45, oops, 90. So when you draw these through, 1, root 3, and a 2. 1, 1, root 2. In order for you to get a tangent value to equal 1, you have to remember, what does tangent mean? Opposite or adjacent. If it's opposite or adjacent and it equals 1, that means your opposite and adjacent has to be the same thing. Okay? Yes, ma'am? Tangent can be 1. Remember, tangent can be 1. Sine and cosine can also be 1. Remember how I did that rough sketch of tangent, how it was, it did this?
Yes.
It's 1 at pi over 4. It's negative 1 and negative pi over 4. At 45 degrees, it's the same as your opposite adjacent, isn't it? That's where you get your tangent to 1. Okay. So here, that means your theta value was pi over 4. So your answer is pi over 4. All of these answers should also be written out in gradients. Obviously, we switch some things up. When we draw our triangles, we'll write 30s and 60s and stuff, because that's usually how you set them up, but your solutions always go radians. So when you're doing these things, whether, and I saw people that were trying to get coterminal angles after converting from radians to degrees. That's just a waste of time. You guys just got to count in terms of pi. Okay, you got to count in terms of pi. So here your answer would have been pi over 4. And you said 21, Sarah?
Yeah.
21 same when you get sine of 0. So if you see sine of 0, what angle has a sine of 0? Well, to get a sine value equal to 0, I'm looking for somewhere between here and here. You have to, when you see 0, then you got to think quadrangles. So look at your ordered pairs. This is 0, negative 1. I'm sorry, 0, 1. This is 1, 0. This is 0, negative 1. Where's sine 0? 0. Answer is 0. The y value. Okay. So if you had cosine of 0, that would have been at pi over 2. Okay. You have to remember, quadrantals end up with zeros and ones. So if you see sine of 0 or cosine of 0, it has to be on a quadrantal. If you see sine of 1 or cosine of 1 or cosine negative 1, it's going to be on a quadrantal. Whereas if you see tangent of 1 or negative 1, it's 45s. Okay.
So then 22 would be like
22 at negative 1, it would be pi. It would be a pi because at 22, cosine at negative 1 is when the x value is negative 1 is over at pi. So yeah. Sorry, I'm like trying to do this backwards in my head. I'm sitting there rotating and looking at it. Yes, the answer is pi. Hi, how are you? Oh, what's almost pi day? It is. We got 10 days. What's up? Negative root 3 over 2. So it was cosine. Okay. Cosine from here to here. If it's negative, it means I have to be in the second quadrant. No. You only wind up unrationalizing if your numerator and denominator are the same. Cosine's what over what? X over r, right? So it's adjacent hypotenuse. There's your root 3, and there's your 2. Your root 3 happens to be negative because it went to the left. So it means your opposite is a 1, so that's a 30-degree here. So your reference angle is pi over 6. Now, pi over 6 isn't in that second quadrant. What's in the second quadrant? Negative. 5 pi over 6, very good. When you get negative value for cosine, it has to be an obtuse angle, the way you search for things. Remember, when you're searching through here, you're looking at a reference angle. How far are you off of the x-axis? That reference angle is 30. It's pi over 6. Okay? The pi over 6, excuse me, is just how far you're off the x. You have to think about how far are you going to the terminal side to make this negative. You have to go 5 pi over 60 to get there. You got to go 5 pi over 60 to get there. Right? It's the 24 that you would look at unrationalized. Okay? So on 24 you've got, and I think 18 it's like that as well. So 24 you have tangent inverse of negative root 3 over 3. So that has to be placed here. This tangent goes negative. Now tangent's opposite over adjacent. So in order to get the root 3's, it has to be a 30, 60, 90 triangle. That's the only one that has the root 3's in it. So when you think about it, and you see root 3 over 3, that means it has to be rationalized, which means the unrationalized version of that, you can do one of two things. You can just multiply by root 3 over root 3, and you'll get negative 3 over 3 root 3, which is negative 1 over root 3. Okay? You can do it that way and it works. Or just know that when you if you have the same radical and the same whatever the number is under the radical, root 2 over 2. The unrationalized version of that is 1 over root 2. Root 3 over 3. The unrationalized version is 1 over root 3. Okay? That's how that stuff works. So here, when you think about your tangent, if it's negative, the negative portion was the y value. Okay, it's your opposite. So there's my negative 1. Here's my adjacent. Which one has the negative 1? That's the 30. So in terms of negative y, it would be negative pi over 6. No, not in this case because tangent. Remember, tangent, you're solving for tangent between pi over 2 to negative pi over 2. Okay? When you're searching for them, when it's just straightforward like this, you're searching for it within the specific quadrant style. Okay? When we get into what are called general solutions and solutions within one revolution, then Sarah, yes, it is also occurring at 5 pi over 6. Because tangent's negative in second and fourth. So then the other angle that has the same reference angle would be that. Okay? We'll get to it. Okay? What was it sine of negative root 2 over 2? So again, you have sine of negative root 2 over 2. Inverse sine negative root 2 over 2. Again, that means this has just been rationalized, which means with the root 2's, it has to be a 45. It's negative this direction. So here's your negative 1, here's your positive 1, there's your root 2. So what angle is that? It's a 45, but it's down, so it's negative pi over 4. Okay, it's negative pi over 4. That's the other trick with a lot of these things. When you see, if you go back to the style of what is the secant of 11 pi over 4. When you see that denominator before, what's the angle going to wind up being? Has to be a 45. Okay? You have to figure out what quadrant you land in. If the denominator is a 3, what's the angle going to be? 60. If the denominator is a 6, what's it going to be? 30. If it ends in a 0, it's probably a quadrantal. I'll figure that out. Quadrantals all end in zeros, don't they? Convenient. Okay. So I'm seeing a lot of scariness here. Lots of scariness. I think, oops, go back to the board. Change one, that one, did this one. Cosine negative 1, like we said, pi. Sine of negative 1 would have been at negative pi over 2. Negative pi over 2. Then we did tangent and the cosine of the root 3 and the 2, that has to be a 30, 60, 90, with your adjacent being the negative root 3. So that would be second quadrant, and your opposite ones, that was the 5. Oh, we did that was 5 pi over 6. Okay. And that's how the stuff looks. You all right, Brie?
I'm existing.
Well, I know you're more than existing. You just kind of had that little troublesome look.
Yeah,
Which
I
part?
don't understand.
Which part?
It's coming along. It's more like the stuff on the other paper.
Which one?
Like this one.
Okay. Which one will look at?
Literally any of them.
Pick one.
Let's do sine.
Sine of what?
300.
Okay. So this is the sheet that you guys got yesterday as well.
Yeah.
Okay. So when you have ones like this, the goal is, first thing you always do, you draw it and you figure out where it's going to land. Okay. Now this one, I was saying like, oh, if it ends into zeros, could be a quadrantal. In this case, it's not, because how far is this off of 360? 60, so you know what your reference angle is. Okay. So we know that we are in the fourth quadrant. We draw and come back up. I know that this has to be a 60 degree. What's opposite your 60? The root 3. Now, since the vertical is down, that means this is the negative root 3. Adjacent to use the 1, and there's your 2. Sine is opposite over hypotenuse. What's your opposite? The negative root 3. What's your hypotenuse? Your answer is negative root 3 over 2. Okay. Pick another one, Rick.
Sine of negative 17 pi.
Negative 17 pi over 3. Okay? Okay. Again, mixed number helps tremendously. 3 goes into 17 how many times? 5, and how many are left over? 2. Denominator's a 3, which means you know your reference angle. It's going to be a 60. You just got to figure out where it's at. Okay? So we have negative 5 and 2 pi over 3. So we have to go clockwise. Ready? 1 little, 2 little, 3 little pies, 4 little, 5 little. Now I have to go 2/3. 2/3, is it more or less than halfway?
More.
You break a 20, I'd like to see how you would change. Comes over here, and it drops. We know the reference angle is going to be pi over 3, which is 60. Again, opposite's the root 3, adjacent's the 1, there's your 2. What's your sign? With 3 over 2. You gotta spin it to win it. Read another one. Which one? Cotangent, 19 pi over 6. Okay, right off the bat, what's your denominator? 6. What should be your reference angle? 30. See where I'm going with this?
Yeah.
These are little subtle tricks you should be picking up on as you go through. 6 goes into 19 how many times? 3, and how many are left over? So it's 3, and then it's a pi over 6. So 1 pi over 6. So we got to count. Ready? 1 little, 2 little, 3. And then it dropped 1/6. So I'm going to be third quadrant. Oops. Pi over 6 is a 30-degree reference angle. So this is a -1, this is a negative root 3, and this is a positive 2 for when I draw my triangle. Now, cotangent is the reciprocal of tangent. Tangent would be opposite over adjacent. Cotangent would be adjacent over opposite. So it would be negative root 3 over -1, which is root 3.
Can you do the sign of
-225?
sign of negative?
Oh, yeah. So sine -225. Okay. -225, is that more or less than -180? More. It ends at a 5, so what do you think your reference is going to be? So you come around. So here's your reference. It's 45, so it's +1 to -1 and a root 2. Sine's positive in the second quadrant, so it's got to be 1 over root 2, otherwise known as root 2 over 2. Okay.
Sorry.
No, it's okay. What do you got?
I'm doing the other one.
Which one?
The cotangent. But is it?
Cotangent with what?
Yeah, but it's either wrong.
Okay, see. Come on.
No, I need this.
Yes, sir.
So, can you go back to the sine of -17 pi over 3? I don't know the question.
Yeah, what do you got?
So when we did all the turns and stuff, and then we got to oh wait, never mind. I thought it was 2 pi over 5. Yeah.
Oh, it's okay.
No, it's not.
My handwriting is subpar, so it's all right. All right. What else? Let's keep going. This is what you guys can work on. I know that. Secant of 510. $510 is obviously more than 1 revolution. Is it more than 1.5 revolutions? 1.5 revolutions is how many? Like 540. So it's less than 1.5 turns. So if we go around 360. Now one of the things you can do when you're in degree mode, if you just back out 360, it gives you the positive reference angle. Oh, look at that. So you're at 150. So that brings you second quadrant with a reference angle of 30. 1, negative root 3, and a 2. Secant is the reciprocal of cosine. Okay? So cosine would have been negative root 3 over 2, whereas secant is going to be 2 over negative root 3. So it's negative 2 root 3 over 3. So now you just secant destroyed that. Wow.
They're on that sheet.
Yep.
Is there a bag?
Yeah. Did you see?
What is it? I had it.
That's a thing from back when I was a kid. Yes. Yeah, there you go. That was a thing back then.
Yeah, I should have chosen before my
I also saw Jolt Cola. You guys ever heard of that?
Yeah, I tried it. It's really gross.
It's horrible. I saw it. It used to be like all the rage way back in my day. We were camping somewhere up in not Lake Erie. It was way north. It was almost kind of by Galena-ish. So far north, west corner of Illinois. Mississippi Palisades, is that right? Okay, so we're up in that one. That's Iowa. I don't know, somewhere over there. We went to a dollar store in Iowa just because it was right there. Because we had nothing else to do. It was 700 degrees out. So we saw Jolt Cola for a bottle. And I really wanted to try it. But then my wife said, "You don't need that much caffeine." I said, "Yes, I do." My wife's like, so I didn't try it. That wasn't really much of a story, but whatever. Yes, I do. Which one? Which one? Pick one. You got it.
Don't go to their little
Well, it's not coterminal. You mean
No, I.
it's quadrantic.
The con-terminal angle is like.
Gotcha. Okay. So coterminal. When you're doing coterminal, remember, it's a matter of. Just trying to look at some of the work really easy. Look at 9 pi over 4. If I want to find coterminal angles, positive and negative coterminal angles of 9 pi over 4, is 9 pi over 4 more or less than 1 revolution? It's more. So what I need to do is get it within 1 revolution. So what I do here is, I know that 9 pi over 4 is basically 2 1/4. So if I back out 8 pi over 4, just to keep it as the common denominator, that gives me pi over 4. There's your positive coterminal, because it's now within 1 revolution. Okay. I subtract it again to get the negative. So if I subtract again another 8 pi over 4, I would get negative 7 pi over 4. There's my negative.
So let me get this straight. So if it is more than 1 revolution, you double subtract. But if it's less than 1 revolution,
You double add.
double add.
Yep, you just add subtract multiples of 360 to get within 1 revolution, either positive or negative, and that becomes your first positive or your first negative. And then you just add it or subtract again to go depending on which way you're going. Okay. It would have been the same thing if this would, like, you're just saying if this was negative 13 pi over 2, make it crazy. Negative 13 pi over 2 obviously is more than 1 revolution. It's more than 1 revolution. Wait, yeah, 1 revolution. Hey, no, I didn't. It's this way.
No, you were supposed to. I did negative, so yeah, you're right.
Well, but since it's negative, it's caught.
Yeah.
Do you have any idea how hard it is to show you guys going this?
Yes, I do. Because you made me do it.
Yeah.
Oh, yeah, that's right. Well, I need to do whatever I want because
It's just my first.
It's been a while.
it has been a while. We haven't really annoyed her that much.
It's been a while since.
That's a great Simpsons episode where the bus driver, don't talk to the bus driver, he taps the sign, don't talk to the bus driver. Homer's asking a question, he's like, don't make me touch the sign again. Anyway, so 2 goes into 13 how many times? And how many are left over? 1. So this is the same thing, yeah, 1/2 pi, whatever, however you want to say it's fine. This is negative 6 and 1 pi over 2, or pi over 2, however you want to write it. Okay. If I back out, since this one is more than 2 revolutions, what I would do is just back out things of 2 pi. So I would have to add 2, I'd get to negative 4, I'd add 2, I get to negative 2, I'm still beyond, I'd add 2 again, and now I'm at just pi over 2, negative. It's still negative. That would be my first negative coterminal. And then I would add 2 pi one more time as I'm going within, but instead of adding 2 to this, I would add it 4 pi over 2, just to keep the fractions easy. If I add 4 pi over 2 to that, I get 3 pi over 2. Okay. Correct. So you're starting negative and you're working your way positive. Okay. And it could be really anything as he goes through that. Okay. It could be really anything through those. The other style that you could wind up with. One of the things that I did not mention when we were talking about inverses, as you guys get into pre-calc, they might not just say sine inverse, they might not say this, they might say, means the same thing. So you see arc sine, arc cosine, arc tangent, arc cotangent, any of those, it means the same thing as it's inverse. It's the same thing, it means the same thing. Okay. Yeah, arc sine, arc cotangent, that means the same thing. So, what I'd like you to do, flip over to number 27. Number what? 27. So, what would you do? Yeah. So, in this case here, where do you start? Yeah. You start with your innermost parenthesis. You start at your innermost parenthesis. It's just order of operations. Okay. So this innermost parenthesis says what angle has a tangent of √3. Okay. So I go to what angle has a tangent of √3. Well, √3s with tangents. Well, that means the opposite's the √3. The adjacent has to be a 1. So what's your angle there? 60 degrees. So I know it has to be 60 degrees. So now, what's the sine of 60 degrees? Oh, see. What's that, sir? Your tangent is opposite over adjacent, so your opposite has to be the √3 to get your adjacent to be 1. So what's opposite the... Right. This means what angle has a tangent value of √3. So what angle has an opposite of √3 and adjacent of 1?
Put that on the test.
Okay. So you got that one. Let's see. Look at 26. Arc cosine of sine of pi over 3. Okay. So that means what angle has the cosine of the sine of pi over 3. So first thing I do is work innermost. What's the sine of pi over 3? Well, pi over 3 has what for a reference angle? 60. Okay. What's opposite the 60? √3. So here's your √3, and then here's your 2, and here's your 1. So that means the sine of pi over 3 is √3 over 2. Okay. The question now is, you've simplified that innermost parenthesis. The question then becomes arc cosine, or if you want to think of it this way, cosine inverse of √3 over 2. What angle has a cosine then of √3 over 2? If it was pi over 3, that would be your 60, and that would have been 1/2. So, again, go back and redraw if you have to. It's got to be first quadrant because you're positive. Cosine is what over what? Adjacent over hypotenuse, which means my adjacent now is the root 3. And now this is my 30, so this is my pi over 6. They're little puzzles. They're little puzzles.
Oh, wait. Yeah.
Number 7 says arc sine inverse. Oh wait, that's kind of weird. Arc sine inverse of -1/2.
Yeah, it's just like.
It does, because that just means what's the sine of -1/2, and you need a calculator for that. That won't work. So you can cross that. You can cross that one out.
Which one?
Yeah, 7. 7 is basically undoing itself. The inverse of an inverse is itself. So you'd have to use a calculator. As you know, the stuff that crossed off the bottom here, some of these things would have calculators stuff to it. We just didn't get. We're just not doing the calculator portions of any of the stuff in here. I'll let you guys do that later. Okay. Don't cross off 7. 7's all. It's just it's a. What about the cosine? Oh, remember arc cosine means the same thing as inverse cosine. It means the same thing. Yes, sir. Oh. All right. Let's see. So knock through this and I guess when I wrote this stuff up, I probably shouldn't have made all the pictures for you. That's too easy. Now, one of the things that I've noticed is that we really need to do more problems. Whereas you guys need to do more problems. I don't think we've had enough of them for the practice. Okay? And this is one of those moments where I've realized that I am not a huge proponent of extra work, but right now the practice is needed to make sure that this stuff continues to do well. Because it hasn't been going very well this past few days. Okay. So I gave you guys 2 sets of things. I want you to knock through as much of this as possible. I want you guys to be ready to ask a bunch of questions tomorrow. We will go through this stuff. I will show you the last little bit of reminding of the right triangle things, which are on the last bit of the stuff I just gave you. And we're just going to do this on Friday. Now we don't have to do IDs over a weekend, because you're going to be pissed at me anyway. We have to do trig identities. It's going to be great. It's proofs. You guys are going to love it. Yep. So you guys went through trigonometric proofs starting Monday. Those will take a good solid 3 to 4 days. Then we'll get into what? We have to do trigonometric proofs, and then after that we go to trigonometric. Then we get into trigonometric equations that you have to do identities with and factor. And oh yeah, there's factoring with trig. Comes back. It all comes back. So we'll get through all of that. Like I still see us being done with the trig IDs, the trig equations, probably by that Thursday before spring break. I want to make sure I get the test like at least a day or 2 before the last day before spring break, so that way people are dead. They get it before they leave, because they're not going to be happy when they have to come back after 10 days off, and 10 days off, and they have to do it then. What's up? Why would I do that? I wouldn't
Remember when
expect
Miss Mary gave us that packet?
I would never do something to break. It's just stupid.
Our seventh grade teacher gave us that packet.
I wouldn't expect you to do it. Yes, ma'am. What you got? What's up? Yeah, we haven't gone through that. That's one of the things I want to talk about. Yeah. Everything you've done with that calculator is going to be there. Everything that we've done with that calculator will be on there.
So this you just kind of do one step at a time.